Okey. Kita kembali ke dalam kelas kita semula, sesi petang. So, semua sudah kenyang. Ada berapa orang ni? 2, 6. Hazira tak ada. Hazira dah balik. Okey. Okey, kalau kita tengok balik pagi tadi, kita telah sampai ke apa ni, catalyst dan athlete. Okey, now is a process of polymerizations. Polymerizations ni adalah proses untuk membuat polimer lah, pre-polymer. Actually dia pre-polymer and polymer ni is the same, cuma is apa ni, dia polymer ni lebih besar, lebih panjang, lebih banyak ethylene yang apa ni disalut lah. Jadi dia punya molekul tu lebih besar compare dengan pre-polymer. Pre-polymer tu dah bentuk powder, bentuk powder yang halus lah, macam bedak lah. Tapi polymer ni besar lagi, panjang macam apa lah, dia macam plastik yang dipotong-potong di polymer. Okay, jadi sesi petang ni kita start dulu. Sebelum kita start, kita nak buat aktiviti dulu lah. Kita nak buat aktiviti dulu lah, supaya kita sehat sikit dah petang. Alright. So, apa yang kita nak buat petang ni sebelum kita start kelas adalah saya minta setiap orang boleh berdiri dulu. Boleh berdiri. Apa? Oh, sorry, English. Stand up. Harap, okay, harap. Please. Okay. Alright. So everyone is stand up, and then we need to have in partner. Two. Okay, so we work in partner. What are we going to do untuk petang ini adalah what we are going to do is we have a competition between two of you. Okay, pen. So macam ni cara dia. Your partner is do like this, and another one is like this. So try to catch. One partner is catch like this, and another one is try to catch lah. Okay. Distance is like this distance lah. Okay. Okay. So whoever managed to catch, dapat dia at least close like this lah. Close. Okay. Close like this. At least nearly touch your hand, your hand. Okay. So we are going to play in several rounds. So whoever can catch, 1 point. Whoever cannot catch, 0 point. And drop. Okay, so catch, 1 point.
How many times?
4 times.
4
times. Okay.
Okay.
Yes, belum start lagi. Sabar. Patient. Soft, asam belum minat iman. Dia kena ada music sikit baru ada shock sikit.
Chicken dance.
Kita dah boleh lah musik ni. Okay, so we start to play the first round. Saya cakap saya nak cakap apa? Kita bagi start. Satu. Boleh semua start ya. Okay ya. Ready.
All in one time or one by one?
All in one time. Okay. When I say start, you start ya. Okay. Seorang satu drop, satu pegang. One drop, one person drop, one person and after that change, switch. Okay, start. Start.
Already this one easy.
Oh.
1 point.
Oh.
1 point.
1 point for the penangkap. Okay, round number 2. Switch. Round number 2. Start. Oh, very good catcher everybody. So, okay, semua dapat each 1 point and 1 point. Is it? Oh, draw. Okay, round number 3. Start.
Hampir.
Oh, so switch your pen. Okay, and round number 4. Round number 4. Start. Okay. So, siapa yang menang, siapa yang kalah? Who win, who lose? Seri ya? Seri. Okay. So, everyone got a draw. Thank you. I think this, yeah. Lagu menyeramkan. Okay. Alright. Okay, kita start dekat sini pula. Okay, so back to the pre-polymer. Just back to the pre-polymer tadi. Okay, you understand? This is a step after catalyst and ethylene. So first step is pre-polymerizations. It is exothermic reactions and put in a reactor with additional of Ziegler-Natta to perform reactions and produce a pre-polymerization. So catalyst put in, ethylene put in, hydrogen in and hexane. This is water jacket due to exothermic conditions, and put TNOA, tri and alkyl aluminum to this is a recipe in the reactions lah. Okay, as catalyst initiator. Okay, this is pre-polymerizations and hydrogen gas as a termination agent. Once it's mixed with hydrogen, so it stop the reactions of ethylene. Okay. After pre-polymerization, due to the pre-polymerization occurs in the reactor, so they need to have a dryer, to dry to dry the pre-polymer. This is pre-polymer dryer, heated nitrogen in, nitrogen out, and mix stir. Complete pre-polymerization, pre-polymer transfer D300 dryer, remove adhesive and solvent, sufficient dry before inject to reactor. Drying process in nitrogen flow to remove the remaining adhesive. So the analysis part after this one. This is what we take from the pre-polymerization reactor D300 after dryer. So this is the sample container rolled in plastic bag or round bottom flask with three-way valve. It depends on the analysis whether we want to take round bottom flask just like the catalyst or a plastic bag. Whenever we take a sample with plastic bag, no nitrogen blanket, with round bottom flask three-way valve needs nitrogen blanket. So this is the pre-polymer vessel here inside this. So open to sampling line. Just take the powder. Okay. How when to make this sample representative? So normally the sample will be accumulated here. Previous sample from this vessel accumulate here. So whenever we want to sampling, this line must be cleared first or flushing from the sample before taken into plastic bag. Otherwise, we will get the same sample as previous sample, and the sample whenever they reach a lab must be in warm conditions. So lab technician has to make sure that it's a bit warm. Sometimes it's cold. So cold, that means the sample is the old sample. Sometimes they do a trick. Whenever they want to collect a sample, so this sample is normally 2 hourly or 4 hourly. Whenever dia datang rasa malas ataupun penyakit lazy penyakit malas, lazy disease. So the operator will take 3 samples at one time. So 3 samples, they put it in a room. At 8 a.m. so they send the right sample. At 10 they send the same sample but different plastic bag, different label. At 12 a.m. also the same sample but different label.
When we take the sample, we'll do the analysis direct, or we have to keep the sample first?
Direct analysis. And the result must be out within 2 hours.
2 hours.
Within 2 hours. Depends on the parameters. Because these results need to be produced to control or to adjust the plant conditions. So when operator got the wrong results, so the adjustment will be wrong. Okay. So that's how it works. The plastic bags and so especially in the night shift tend to have a sample. It's a wrong sample lah. It's a wrong sampling or wrong sample or a strict sample lah. So it must be prepare with that conditions. Sometimes the engineer didn't know though. Engineer sometimes they do adjustment, but the sample result is still the same. So why? And then the engineer will discuss with the chemist, lab chemist, why the result is the same after we do some adjustment. So look back at the sampling, how they do sampling. Okay. This is the parameter that we analyze XRF, particle size. The same is same like this catalyst just now. This XRF is using ASTM D1265. D1265 if I'm not mistaken. Ada tulis dekat dalam your slide lah, ASTM.
Kalau dia ospec dia akan masuk balik proses ke?
No.
Dia akan tak
This is one way punya process. Once ospec need to throw it away lah.
so that product memang tak diguna.
Cannot be used.
So, excuse me, you said one time we have to take 3 samples, right?
Uh-huh.
One time.
Uh-huh.
Have to take 3 samples? You said just now.
Okay.
When the operator get the sample, take 1 sample or take 3 samples?
One sample.
One sample.
One sample
What
only.
percentage?
The 3 sample, if they take 3 sample,
Yeah.
is
For
is-
checking, verifying. What?
no. Actually, they trick it. They take a same sample, send at different time, so that you don't need to take another sample. Okay.
Trick.
So you take one time, you got 3 samples, you can send it at different time, so you don't need to take any more sample.
But it's not good practice, huh?
It's not a good practice.
It's wrong.
It's wrong practice lah, but especially during the night shift, that one you need to berhati-hati lah, be careful lah. Actually, it's not good practice. It's a wrong practice already. It's a cheating.
So I mean, from the time to time, there is adjustment between that time
Yes.
when they take in the sample.
Adjustment.
When they do adjustment, they send the sample, or there is a schedule, or what is that?
From the sample that sent, they do adjustment. The results.
Do adjustment.
If the plant is stable, so the sampling is maybe 4 hourly or 6 hourly. Depends on the plant conditions lah. If the
And the parameter is stable. This
yeah,
the parameter. That.
yeah, these parameters lah. This parameter. This is what the product of this product of prepolymer lah, from the Ziegler Natta prepolymer. This is the sample that we take long chain hydrocarbon to perform the polymer. Polymerization is product being controlled melt index and density. Ziegler Natta prepolymer inject into fluidized bed reactor to produce polyethylene powder. So the prepolymer, the powder injected to make the polymer longer. Prepolymer plus ethylene gas as monomer and butene 1 as co-monomer. Hydrogen, a small part of hydrogen mixed together inside this. So the polymer will react and form a polymer lah. Ethylene and prepolymer. Prepolymer is activated catalyst for prepolymerization, and ethylene gas perform a polymer like this lah. This is the reaction. Catalyst with ethylene perform intermediate, and then from intermediate more reaction and produce the long chain. And terminations by hydrogen nantilah, hydrogen. So this one is taking out lah. So in our plastic also actually ada got titanium, got small amount of chromium. It's all dangerous elements. Titanium, magnesium, small amount of chromium is carcinogenic. So just imagine what we are using for our daily life in the plastic. That's why heating the plastic is not good practice. Heating a plastic for food, it's not good practice. Okay, finally, degassing system. Degas, that means degas is minus the gas, minus the gas in the system to take a powder, because we need to withdraw the powder. Powder will withdraw at the atmospheric conditions from the reactor. Primary degasser, secondary degasser, final degasser. This is the process lah actually. The process that polymer going through is just mechanical ataupun it's a process and nothing to do with the nothing to do with the chemical process lah. This is the degas to remove the gas, because inside the reactor ada ethylene, ada hydrogen, we got hexene 1, so need to degas. Okay, so after polyethylene powder, after pre-polymer, so this is powder, polyethylene powder sampling. Just like the same with the pre-polymer just now. The sampling sampling method is same in the plastic. So just open the valve, so the powder will going down. Take the sample and perform analysis. Analysis will be performed after this lah. I discuss to you what is the analysis that I are going to perform. Okay, roll plastic bag. Plastic bag is actually no need to buy. Produced in our own lab. We have a blown film, so do a plastic bag. We have a virgin plastic, virgin mother plastic, so do a plastic bag. Okay, one different material lah. Some material cannot, like the material that for plastic ni normally is a different MI, different density that used for the plastic for the market lah. Not all can do for plastic bag lah. Okay. Okay, so this is the product of the powder. This is this is grade LL, linear low 0209, linear low 3840, different applications. This one LL0209 application is actually for linear low density polyethylene. This one for film products, and this one for rotomolding. Rotomolding ni some of the product is like a huge tank or drums. This is the product. You see here, you see the difference is melt index 2.16, 2.16 is the spec is different. Spec is different product. Density is different spec. This one also different spec. The analysis method is ASTM 1238 and 1505. Okay, for melt index, this is the most important analysis for polymer lah. MI and density. Maybe some of you heard about it lah. Okay, ataupun some of you never heard about it because you never come across, not used in your lab lah. Macam refinery, I don't think we have lah. Okay, and then size and XRF. XRF as usual, titanium. What is melt index and density? MI and density analysis. So what is the analysis that performed?